Hello everyone, welcome back. I am Miss Celeste and today we are going to learn about two very important reactive species, that is electrophiles and nucleophiles. So both these terms are very important and they are very much useful in various chemical reactions. So in this video, I'll be giving you some idea about what are these electrophiles and nucleophiles. First of all, let's learn what are electrophiles. So here the term electro, that means electrons, and philes or philic, that means loving. So we can say that electrophiles are electron loving species. Here are a few key points. First one, they are electron loving species. Okay. Second is there is a presence of an electron deficient atom. So that means electrophiles are those species which are electron poor, or they don't have any electrons in them and they are in need of electrons. That is why it is said they are electron deficient atom. Third point, they are positively charged species. So something which is electron loving, they may be having a positive charge in them. That means there is a deficiency of electron in them. Last point, they are electrically neutral chemical species. Okay, so they may be neutral, that is they may not have any charge, but still they are electron deficient. That is why they are called as electrophiles. There are two types. One is the positive electrophile, another is the neutral electrophiles. Let's learn about each one of these. First one, positive electrophile, that means they will be having a positive charge in them. So whenever you see a positive charge, that means there is a deficiency of electron in them. For example, you can see H plus ion, CH3 plus, NO2 plus, Cl plus, Br plus, Ag plus. So all these positively charged species will act as electrophiles as they are electron deficient species. Second one is the neutral electrophiles. So all these electrophiles, they may not have any charge, but the most important thing is there is a deficiency of electrons in them. That is why they are called as neutral electrophiles. For example, you can see BF3, AlCl3, SO3, ZnCl2, BeCl2, FeCl3, SnCl2, CO2, free radicals, carbenes, nitrines, all these will act as a electrophiles because there is a deficiency of electrons in them and they are in need of electrons. Okay, so these are called as electrophiles. Coming to the next important term, that is nucleophile. So here nucleo means nucleus and philes or philic means loving. So we can say that nucleophiles are nucleus loving species. Let's look at few key points. First one, they are a nucleus loving species. Second, they are electron rich chemical species. That means these species will be having more electrons in them. So that is why they are called as electron rich species. Next, they are negatively charged. So whenever you see a negative charge, that means they will be electron rich. They will be having more electrons in them and they will be acting as a nucleophile. And neutral species, there may be some species which are neutral, that means they doesn't have any charge, but still they are electron rich. Okay, so that is why they are called as nucleophiles. Now, coming to the types of nucleophiles, there are three types. First is the negative nucleophile, second is the neutral nucleophiles, and third is the ambident nucleophiles. Now let's learn about each one of them. First is the negative nucleophiles. So these are those species which are having negative charge in them. That means they are having excess of electrons in them and they will get attracted to the ones which are having positive charge. For example, here you can see OH minus, Cn minus, I minus, Cl minus, OR minus. So all these species will act as a nucleophile. That is negative nucleophiles. Second one is the neutral nucleophiles. So these nucleophiles, they doesn't have any charge in them, okay, but still there are excess of electrons in them, okay, or you can say they may be having some lone pair of electrons. For example, in H2O, oxygen is having lone pair of electron. In NH3, the nitrogen atom is having a lone pair of electron. Similar is the case with RNH2, R2NH, R3N, ROH. So all these are the examples of neutral nucleophiles. So they don't have any charge, but still there is an excess of electron in them. They are electron rich species. So they act as a neutral nucleophiles. Ambivalent nucleophile. The nucleophile which can attack to two or more atoms are called as ambivalent nucleophiles. For example, you can see that CN, cyanide, can attack through nitrogen or carbon to give cyanide or isocyanide. That means either nitrogen will attack or the carbon can attack, and they can give cyanide, RCN, or isocyanide, that is RNC. Okay, so here we have learned about the nucleophiles. That means whenever you look at any electron density or a negative charge, or whenever you see some electron rich species, so they will play a role of nucleophile. Okay, so here we have learned about electrophiles and nucleophiles, and we have seen the different types of these species. So I hope everybody has got an idea about these topics. Now I'll come up with a new topic in my next class. Till then, take care and have a good day. Thank you.